Hello and welcome to the first video in this new series on improving Vice. This series will run a lot slower than the previous programming series on programming a chess engine in C, purely because the testing to improve the engine takes a lot longer. Well, it takes a couple of days for each change I make, and therefore at the very most I expect every 3 or 4 days to have a video release discussing what's going on. In this video though, I want to talk about the first change in result that I've made to Vice to improve it, and by how much, but quickly first of all about what's actually gone on the last few weeks apart from having a very long holiday. When you're testing an engine to improve an engine, what I used to do when I first started in chess programming, which is a good 10 years ago now, is make a change, say the engine doesn't have any king safety evaluation, put some evaluation in, say put the king behind its pawn, so castle either side, and it must be better, the engine, because it's got king safety in. Well, we already saw a bit versus TSCP in the last series that Vice was beating TSCP on level ground where there was no hash table in or anything like this. It had the same search algorithm as TSCP and had far less evaluation, but nevertheless was beating TSCP. And adding king safety or something in may well have changed this, and it may well have started losing. And the only way you can really know whether a change you make to your engine is to test it. And the bad news is when you test, you need a lot of games from against varying opponents from varying starting positions to actually be able to accurately measure whether you've made an improvement or not. And one thing, if you read on talkchess.com or something like that drives programmers and the testers crazy sometimes, is when someone comes in and says, yes, I've got this engine and it's beat this other engine 6-4, therefore is stronger. Well, that's not true at all. And what I did then with Vice at the end of the last series was I spent a lot of time trying to find the quickest possible way of testing Vice reliably. And what I mean by that is that the top engines, so the very strong engines like Houdini, Stockfish, they'll test at very, very fast time controls. So crazy time controls, sort of all moves in 2 seconds plus a 0.1 second increment or something like that. And that way they get tens of thousands of games, especially when they invest a few computers in there as well, played simultaneously, and can tune a lot of variables and things very, very accurately. The problem that I have with Vice trying to do that, whilst it won't lose on time playing that kind of time increment, it'll also only hit probably depth 4 or 5 in the middle game. And that isn't enough really to measure, certainly evaluation changes anyway, very accurately. Because as we saw when we were developing Vice, before it had any improvements to its search, so just the basic alpha beta, the depth was so low that if you put in evaluation a bit like TSCP's, for example, where you have very, very high, stupidly high evaluation for passed pawns, it'll often win a lot of games against equal opposition purely because the pawns have gone forward and then both engines realise too late that the pawn's actually promoting. And lots of things like that, so it's good maybe to get to 7, 8, depth 9 in the middle game if possible. And unfortunately with Vice the way it is at the moment, that means taking around 60 seconds for 60 moves, around a second a move, plus a second increment. So what I then did was went through a whole list of, in CCRL, the ratings list from top to bottom, and had around 30 opponents, and tried to find a set of opponents that would play against Vice having a very fast time control, so the games were over quicker, but still gave Vice a good game. So eventually I settled on 5 opponents, Spike, Philo, Ruffian, Diablo05 and Pupsy, and I ran then Vice in what I called Base A, which was a 5,000 game test, 1,000 games against each, using the first 500 or 4,000 start positions that Bob Hyatt provides, which are sort of relatively equal, very varied opening positions, playing each as white and black. And as I said, these guys all had 2 seconds for 60 moves plus 0.2 second increment, and Vice had 60 seconds for 60 moves plus a second increment. And the interesting thing from the results, or the rather depressing thing from the results really, is even after 5,000 games, the error margin on the ELO for Vice is plus or minus 8 ELO, which means if I want to use this 5,000 game method for improving Vice, every change I make must at least be outside this error margin. So you're looking maybe around 16 ELO or something, or around there. Take the squares really of them both added to the square root of them both added together, the squares of them both added together to get the true sort of error margin. But let's say around 16 ELO improvement to definitely be able to say after the test, yes, I've beaten the old version. So it could well be that after implementing the first 2 or 3 very obvious improvements to the engine, that I'm going to have to increase the testing games up to maybe 15,000 or something like that to actually be able to accurately say whether the engine has been improved or not. So when you see this, you begin to realize why, even when you play 20 games at home or something on the computer with 2 engines together, it's impossible to say whether one is better than the other until you've gone outside the error margin. Now, of course, if you've got something like an 800 ELO difference after 20 games, the error margin won't be 800 ELO, and you can already safely say, yes, one is better than the other. But even with the error margin on 1,000 games here is plus or minus 17, so you can already see that you need quite a lot of games when engines are similar in strength to determine whether they're better or not. So anyway, I played these matches then on a quad-core computer that I've got spare lying around, and used 3 of the cores simultaneously, concurrently, to leave 1 spare for the OS. And then with the base B, I ran the same test again, exactly the same conditions, to see how similar the result was. And it was 4 ELO different according to this, but well within the error margin, and 1% difference in the score for Vice, 43 and 44%. So it wasn't quite as close as I would have liked, and just underlines that probably 5,000 games is right on the lower limit of games that need to be played to judge the improvements in Vice, but hey, I've only got 1 computer and I haven't got forever. So what have I done then for the first test result, which is the subject of this video? Well, I added in one very simple improvement that comes from Bruce Moreland's site again, and it's called PVS, or Principal Variation Search. And it's a small change into the alpha beta algorithm. Where are we? Here we are. We're in the move loop section here. Loop through the moves. And just before, I've set here a flag saying found principal variation, found PV is false. And what you do is you have this if statement here, which I'll explain the contents of in a moment. But whilst found PV is false, we search with the normal minus beta minus alpha window through the tree. And then if alpha gets improved, then we say that we found our PV. So found PV is set to true. And what we do then is we then search with a window of minus beta minus alpha minus 1 and minus alpha. So if you imagine that alpha and beta were minus 100 and plus 100, normally then when we search for the opponent going into calling alpha beta, he also then has a minus 100 plus 100 because it's minus beta minus alpha window. But when we send in minus alpha minus 1 minus alpha, then it would actually have 99 and 100 as the window. And what we're effectively saying with this is we've already found a move that's beaten alpha. Our move ordering is very good, as we nearly always find the best move first. And therefore, we'll assume that the opponent isn't going to make a beta cutoff. Or, for us, the score returned from the opponent isn't going to be greater than alpha. And obviously, because the window has gone from minus 100 to 100, it's gone from that to 99 to 100, it means that a lot fewer moves are then searched. However, the problem comes then if the score does beat alpha, then we have to search with the full alpha beta window to get a proper score for that move. But in general, this small improvement, just doing this algorithm here, does actually give an improvement. And indeed, when I ran this test with the 5,000 games with Vice, it did give an improvement. You can see the result here. And it's actually an improvement that, thank goodness, is outside the error margin. So I can safely say here that Vice has 10A, which is the version with the principal variation search, is better than Vice 1.0. It was fairly close when you take into the error margin into account, but still was far enough away. And I also used Bayes ELO to make a quick likelihood of superiority table, where people say generally 98 and above is also a result where you can safely say there's been an improvement. And the result was that Vice 1.0a is 99% certain to be better than Vice 1.0. So that's the first improvement for Vice. It's a small improvement. It's probably an improvement of maybe 10 ELO or so, I don't know, because of the error margins here, but it's an improvement nonetheless. It's not enough probably to release a new version yet, but anyway, the road has started to improving. So that's it for this video. I hope it hasn't been too dull or boring, so there's lots of explanation and not much programming or anything. And I'll be using this series to release a video every now and again just to keep you up to date on the progress that I've been making with Vice. So thanks very much for watching. Comments, questions, criticisms, welcome as always on YouTube.